Okay, today we're going to discuss mole to mole conversions. First, mole to mole ratios. That's in a specific chemical reaction, how much of a reactant you might need to react with another type, or how much reactant you might need to produce a certain amount of product, or how much product that you might make with a certain amount of reactant, so forth. And we're going to do mole ratios. Okay, we're not going to do grams, so start with moles. Okay, so first I'm going to start with something you might be familiar with, a reaction of glucose, that's C6H12O6, with oxygen. Strange type of combustion, right? And it's going to make CO2 plus H2O. This might look really familiar, especially if you're used to biology. This is cellular respiration equation. And then reverse photosynthesis. Okay, we talked about doing the rainbow method for balancing. I'm just going to go over it one more time. Kind of just look and see what looks weird. If you have something by itself, save that for the end, all right? Especially oxygen and something like that. Sometimes it's hydrogen gas, because you can always adjust this without affecting something else. So anytime you adjust one of the other atoms, you affect the other atoms in the molecule. So right now I can say, oh, cool. I noticed that the carbons are off. Okay, the carbons are here and here. So rainbow method, or leapfrog, however you want to say. I say I got 6 carbons here. Are they going to want one there? Okay. You're like, why do we do that? Well, we'll kind of come back to that. So I'm going to try a 6 here. All right, so that's going to make that 6. That's awesome. Okay, remember I said I save oxygen for the last. So we're going to go back here and do the hydrogen. Okay. Hydrogen, I got 12, because that's what that little coefficient or little subscript means, excuse me. Coefficients are the numbers out front. The multipliers out front, they tell you how many sets of molecules, right? Coefficients are how many atoms in that molecule. All right, so 12 here, and we go over here, only 2. So you need to make that into 12, all right? You multiply by 6, and you'll get 12. Just change that 2 to the 12. Okay, now we've done the hydrogen and the carbons. Now we do oxygens, which is a tiny bit more tricky because it's in 2 different places. However, it's easy to adjust if we can just save that number for the end. All right, so 6 oxygens here. I'm going to go for the top just to make it less cluttered on the bottom. All right. Yes, 1 oxygen times 6 is 6. This is 6 sets of 2, so that's 12 oxygen. All right, total is 18. Okay, so we need to make 18 from this and this. We need 2 sources of oxygen. They just have to total 18. We already have 6 here, so 6. Subtract 6 from 18 and you get 12. So I need 12 from here. All right. So I can deduce that I need a coefficient of, what times 2 is 12. That is 6. All right. Now, I teach you, when you do these, to go back and check your work. I happen to know these are the coefficients for cellular respiration. 666. Super. Now we're going to talk about mole ratios. So what this means, of course, if it's blank, it means 1, right? In chemistry, we're lazy. We don't put the 1s if we don't need to. It's already there at one time, so it's 1. So it actually means, it could mean, since it's a ratio, it could mean 1 molecule of glucose reacts with 6 molecules of oxygen to produce 6 molecules of CO2 and 6 molecules of water, okay? This could also mean sets of molecules, like 1 dozen glucose molecules reacts with 6 dozen oxygen and produces 6 dozen carbon dioxide and 6 dozen H2O. All right, so this is a ratio, but we have this great large quantity of atoms because it makes things easier to deal with since we're always dealing with large quantities. And we can say moles. These could be mole ratios, and that's what we usually use these for too. So it could be 1 mole. We don't need to put the 1 up there, of glucose reacts with 6 moles of oxygen to produce 6 moles of CO2 and 6 moles of water. Okay, so that, you think, well, who cares? Well, it puts things in ratios of atoms, okay? And molar quantities are just easier to use, plus we have this convenient molar mass, which uses grams to moles. And I'll find out later that's super important. Then we can turn things into a ratio and we can figure out how much product, for example, in weight that we're going to have. All right, but first things first, we're going to just do mole to mole ratios. Okay, so just as a good exercise, the ratios. If you wanted to know a ratio of something to something else, sometimes you put it like a colon, right? So this many moles, I left off moles. I'll just put molar ratio, right? So you know this is all just moles. Okay, so moles to, of glucose to oxygen, you could fill that in. You could be like, okay, well, one of these, just use the coefficients, right? Will react with 6 of those. So in this reaction, you're gonna have a 1-to-6 ratio. Okay. Let's see. So ratios of glucose to carbon dioxide, for example, happens to also be 1-to-6, and the ratio of glucose to water is also 1-to-6. Now, these also could be ratios of the two products to each other, right? Or the products to oxygen. So you could keep going, and you could do ratio of oxygen to CO2. We already have the ratio of glucose to oxygen up here, because it's the same thing, folks. If you have 1 mole of glucose, it reacts with 6 moles of oxygen total. Or if you had 6 moles of oxygen, it would want to react fully with 1 mole of glucose. So these could go either way, all right? But it is important to realize where the 6 goes and where the 1 goes, etc. All right, so it looks like we have a 6-to-6 ratio of oxygen to CO2, which could translate to a 1-to-1. Okay, so I don't know what you want to do. Write 6-to-6, and then you could reduce and say, yeah, so for every 1 oxygen mole of oxygen, 1 mole of CO2 could be produced. For every 2 moles of oxygen, you could have 2 moles of CO2, even vice versa. If you had 3 moles of CO2 produced, it would need 3 moles of oxygen to react, all right? So those are always set ratios in these reactions. Same thing with the water. It is 6-to-6. That could be reduced to 1-to-1. That's the simplest ratio. And then, of course, the CO2 to H2O. And in this case, it's kind of obvious. Should be 1-to-1, right? If you're producing 1 mole of water, for example, that might be easier to measure. You also produced 1 mole of CO2, and yeah, that'd be in gas form. So, yeah, that might be harder to measure, but I don't know. Get to collect the gas, I guess. So we're going to use these in calculations. Yeah, you're like, so what? Why did we do these? Let's say you had 4 moles of oxygen. All right, then let's say you want to see how much glucose would react with 4 moles of oxygen if you only had 4 moles of oxygen. Okay, there you go. So we start with what you have. You always start with what you have, you know? That's important in life. And then make something of it, right? Can't start with what you don't have. Okay, in this chemistry class, we like to do ratio conversions. We don't do equations. You can do an equation, and some of you guys are used to that, where you put the same units on the same side. But what we're gonna do is unit cancellation, because when these get more complex, you're gonna be stacking 3 or 4 conversions on top of each other, and it's easier to do it this way. We just put window. We make actually, some people call this fence posts. But really, what you're doing is you're just multiplying 2 fractions. And then you multiply what you have with the molar ratio, okay? So the molar ratio is a true statement based off of the coefficients on the chemical reaction, and it's always true. The interesting thing is you need the glucose to oxygen molar ratio, okay? You need this one up here, the 1-to-6. You gotta put the 1 in the right place and the 6 in the right place if you're gonna be multiplying this. How you remember is you wanna get rid of moles of O2. We're going to use unit cancellation. If you do it another way, that's totally fine. That's beautiful. That's wonderful. You're still going to do almost the same thing. So you put the moles of oxygen that we know goes with the moles of the glucose, C6H12O6, right? And you multiply the tops. Moles of O2 cancels out with moles of O2. So you get this is moles of glucose. It's very important to put your units down, because sometimes we're using grams, sometimes we're using moles. So put the units and what it is that you're dealing with here. So it's 4/6. We're not done, right? we have a ratio here, or an answer is in a fraction, and you want to simplify. I do know that for 6 will reduce to 2/3, right? Yay! So let's say 0.66 repeating, okay? Technically, because these molar ratios, I mean, if it was exact, it depends on how many, for significant figures. If it was exactly 4.0 moles, you know, that'd be 2 significant figures right there, for one for the 4, one for the 0. So we could do 0.66 moles, okay, of C6H12O6. Sorry, ran out of room. That's your answer. That's how much glucose you need to completely react with 4 moles of oxygen, okay? Most likely, though, we also would be seeing like how much product we could make. So let's do one more. It's just some product. And yeah, we're going to say, using the coefficients, what should we say? I want to make 2.5 moles of water. I don't know, just for fun. Okay, so how much, this time, let's go the other way. Let's go to product. How much water would be produced by reacting 2.5 moles of glucose? Maybe you can look at it and maybe you can figure out. Awesome. But when we are stacking all of these calculations on top of each other, you're gonna need to write down stuff. So in my class too, gotta write down stuff normally for tests. So start with what you have, right? You have 2.5 moles, or supposedly like that's the number you know, right? Theoretically. All right. And then we're going to multiply by the molar ratio. Molar ratio, you know, you're going to put the moles of C6H12O6 on the bottom, so it'll cancel out. And what we can get to is water, right? Moles of water, since these are all, we're going to do molar ratios. Okay, so we know from up here, the ratio of the water to the glucose was 1 to 6. You can do it that way, or you can look directly at your chemical reaction and go, oh, okay, 6 goes with water, 1 goes with the glucose, from 1 mole of glucose being reacted to produce 6 moles of water. So that's a ratio you can do. Yep, in this case, you're multiplying tops, right? What do we got here? 12 plus 3, 15. Yeah, 15 moles of what? Well, doing unit cancellation, which, yeah, if you're not familiar with, maybe go back to talk to your math teacher. You want to not learn math from me. Okay, that's how many moles of water would be produced if you reacted 2.5 moles of glucose. So you do the same thing over and over again. If you're just doing mole to mole conversion, that's what this is, mole to mole conversion, using a chemical equation. And I'm going to give you a worksheet, and you can practice that, and then we'll go over how to do that and some answers. Just make sure you did it right the next day, tomorrow. Okay, make sure you ask me questions, and I hope you're having a good day and enjoying some nice weather. All right, see you soon.